Explicit backing fields is a new feature introduced in Kotlin 2.3. It is designed to be a replacement for this backing property pattern. The idea behind backing property is that we have two properties, one for internal use, which is typically mutable, and one for external use, which hides the first one behind read-only interface. This way, inside a class, we can both read and modify object, and outside of it, we can only read it without modifying it. The idea behind backing property fields is pretty simple. It allows us to define a property of read-only type that is backed by a mutable type, mutable object, and for internal usages, this property of type, in this case stateflow, is casted to the underlying field type, in this case mutable stateflow. So we have the same result. For internal use, we can both read and modify property. For external usages, we can only read it, but we cannot modify it. This feature requires not only Kotlin at least 2.3, but also explicit backing fields compiler argument. The group who benefits most from this feature is Android developers. In Android, it is a standard practice to represent state using stateflow, which is a representation of observable state, typically backed by mutable stateflow, which is, of course, mutable. Thanks to this feature, we can expose externally stateflow type and internally have mutable stateflow, so internally we can read and write it. Externally, we can only read and observe it. We can do the same for shared flow. Shared flow is a representation for events, rarely used on view models, rather used on upper layers of our application in services, repositories, etc. Or if you have a legacy project, you can use it for live data, or if you prefer, depending on snapshot state, you can use it for state and mutable state. Of course, for mutable state, we don't need to use this explicit backing field. A common pattern is to use property delegation to mutable state flow, mutable state of, and specify private set. Now, where is this feature dangerous? One situation where I think this feature shouldn't be used is to expose collections like list, set, or map. In theory, we can use this feature for collections. For instance, if you have some user repository, you can specify property users of type list and back it by a mutable list. This way, internally, you can modify this list. Externally, you cannot modify it because the exposed type is list. However, this is a very dangerous pattern that I recommend to avoid. Why? Because if you do that, you are exposing list you're exposing mutable list hidden behind list interface. As much as this is perfectly fine for a stateflow or shared flow, because for stateflow or shared flow we expect the underlying value to change, I don't think it is okay for collections. Because consider the following situation. When you read list of users, in a result you can see read-only interface list. Seeing that, you might expect that this list isn't changing. But it is changing because it's just a reference to underlying mutable list. So if I get users, I have only user one. If I modify a repository, if I add user to the repository, not only users inside this repository changes, but also this users list, because this users list is nothing else but a reference to this underlying mutable list of. This is an extremely dangerous situation that can very easily lead to mistakes in our code. When we expose collections, we should expose them in a way that returned read-only type isn't backed by a collection that is later changing. So returned list shouldn't change anymore. In other words, there are two ways how to represent our users correctly. One approach is to use backing property. And what is important, make a copy when we expose it. This way, returned list is a copy of the previous of the collection from the moment when we ask for it, and it won't change afterwards. Another approach is to use read-only list and read-write property. So var users, which can be which should be list of string, and to limit mutability, we can use private set. Now, instead of adding an element to a mutable collection, we must make a copy with additional element. This approach is slightly simpler, but it has a completely different performance profile than this approach. In this approach, adding element is very cheap because adding element to a mutable list costs us very little. But exposing users is expensive because it requires making a copy. In this approach, we have the opposite situation. Exposing is for free because we just refer to this read-only collection, but modifications require making a copy of our users. As much as for small collections with up to 100 users, it makes practically no difference. If we expect our list of users to be big, this approach might cost us lots of memory and some performance, assuming we are adding elements more often than we are exposing a list of users. This is why a decision which of those to choose should be made not only based on convenience, but also on our judgment of how those properties will be used. The topic of performance optimization, safety, and issues with synchronization when multiple threads are accessing the same property. That's another problem that should be considered when we choose between those two properties. Is discussed. I discuss on my workshop, Kotlin Mastery, which concentrates on safety and performance optimization. So it discusses problems with mutability, how to deal with them, problems with concurrent access, how to deal with them, how to recognize them, and problems with performance and memory leaks, how to deal with them. If you're interested in different Kotlin features, including explicit packing fields, I discuss them. I discuss everything that I considered strongly related to Kotlin ecosystem in my books, from Kotlin Essentials, Functional Kotlin, Advanced Kotlin, Kotlin Coroutines, and Effective Kotlins. They cover the most important Kotlin related topics, from essential features, advanced features like KSP compiler, plugins, reflection, etc., Kotlin coroutines up to the best practices. This is everything I prepared for you today. I hope that you will enjoy using explicit backing fields. This is a great addition for, especially for Android developers, and I wish you happy coding in Kotlin.